from 5.2. All right, when you're talking about similarity versus congruence, the distinction is congruence. When figures are congruent, they're equal in all respects. Everything about them is the same. They're other than being two distinct items or figures. When you're dealing with similar figures, however, they're not exactly the same. They're just scaled versions of the same thing. So, similar figures have two conditions that have to be met. Okay, all the corresponding angles are going to be equal. Okay, so if two things are similar, then all the angles that correspond to one another are exactly the same measure. And their sides, or all the corresponding sides, are proportional. Okay, so that means that for them to be proportional means that they have the same ratio. Okay, so if you have two squares, obviously all the corresponding angles are equal to one another, not necessarily in the same figure, but just to all the corresponding pieces. And then in a square, if one square is exactly half the length of the other, that would be true for all sides. So they'd all have the same ratio of sides. That means that they would be proportional. And so this works for triangles. Right? The symbol for similar is this mark here. It's called the tilde. It's located on right to the left of the 1 key on your keyboards. So if you ever have to type in a similar to symbol, that's what it would be. Okay. So if you're talking about similar triangles, you can express them just by looking at two figures. If you were told that these are similar, ABC and XYZ, again, just to be consistent and look at this easily. Based on the fact of this first condition, we could make the statement that all corresponding angles are equal. So measure of angle 1, which is equal to angle X. Measure of angle A is equal to measure of angle X. Measure of angle B is equal to measure of angle Y. And finally, measure of angle C is equal to the measure of angle Z. Okay, so there's the first condition. All corresponding angles are equal. The second condition has to do with the ratio of their sides. And so if you take any given side, so let's say we begin with AB. AB in this larger triangle corresponds with the same piece, or the corresponding location of that piece, XY. So that's the ratio for all corresponding pieces. So if you're looking at the ratio of BC to its corresponding side, YZ, it's going to have the same ratio. You could also look for the ratio of the bottom, CA, over the bottom of the other triangle. So all of those ratios will hold true. Now you're not going to use all three of them. You'll use any two at a given time. Okay? But those are the relationships that will exist if you're told that triangles are similar. And just like congruence patterns, you can write a similarity statement. Depending on which order you put your terms in the front, you just need to make sure that your points line up on the back side. And so, again, A corresponded with X, so we need to start with X. The middle term B corresponds with Y, and the last term C corresponds with Z. And so this would be our similarity statement for this set of triangles here. Okay. Also, just like with the congruence patterns, you might start with a picture and you might start with a congruent statement itself. So if I started with a similarity statement itself, if I started with the statement that triangle APX is similar to triangle BPQ, so BRQ. Okay, if I start with this as my similarity statement, okay, then again I can identify all the corresponding pieces of information. the angles that are aligned together are equal. So if I look at the three angles in my first triangle, A, P, and X, A corresponds to B, P corresponds to R, and X corresponds to Q. Okay, so that holds true. And then we also have the ratio of parts. So again, depending on what you start with, and it can be anything. Let's say I start with RQ. RQ is the last two letters, so it corresponds to PX. In the same way that BR corresponds to AP, and in the same way as BQ corresponds to AX. And so you get those ratios all set equal to each other. Again, that's what proportional means. Right, so there's a couple different ways that you're going to see triangles set similar to each other. Oops. And just like congruence patterns, there are some patterns to identify similarity. If we look at the congruence patterns, we had three of them. What were the three congruence patterns for triangle congruence? Liz? SSS is one. So here's the two that involve the two sides, and then there's the two that involve two angles, and those are good. Thank you. Okay, so here are your four congruence patterns. Okay, the similarity patterns are nearly identical. They're built directly off of these. Okay, again, just slightly different. The similarity pattern that you're going to use the most often is the one that kind of combines these two, the AAS and ASA type of pattern. What's common between those two patterns? They each have two angles. So one of the similarity patterns is AA similarity. As long as you have two triangles with a pair or two pairs of angles that correspond and are equal, then you have similar triangles. That means all these other relationships up here would also be true. Okay, and then the remaining two similarity patterns are derived straight from that congruence as well. So there's SSS similarity, SAS similarity. And again, what these stand for or represent here is if you have three proportional sides, then the triangles are similar. If you have two proportional sides and the included angle are equal, then you have similarity of triangles. And then again, finally, two angles equal, then you have similar triangles. Yeah, sorry. And included angle are equal. And so if two sides are proportional and the included angles are equal to each other, you have similarity. And I'll go through and kind of demonstrate each of these